Alright, so I wanted to review here the quiz, our second quiz. This first problem asks for you to be able to do something two different ways. It asks you to show the math, so just with the numbers, and then show with the picture as well how to find the midpoint between these two. So I think the first step would be to actually get those on there. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's this first part, and 2, 1, 2, 3, 4, 5. Alright, I'm actually going to show the compass part first. So that means to find the middle of a line, I'm going to try to find the halfway point by using the fixed radius with the compass, and then where they connect, we know that we could draw a perpendicular line. And in this case, right here, we would line that up, put this dot here, okay, and that must be the middle between them. You could actually draw on that whole line if you want, or you can just leave the points. Both would continue to show the midpoint. So it looks like, just from my picture and from doing it by hand with the compass, it looks like the answer I see is negative 1.5, 1, 2, 3, 4, 5, 6, 7. Okay, let's see if we can prove it with the math here. So again, let's use our coordinates. A midpoint is like the average, it's the middle. So the weird part is we have two middles, the middle of the x's, how far over, and the middle of the y's, how far up and down. So we do have to find the middle of both, because in that sense it has two dimensions that we need to be aware of. So we go negative 5, which is the first x, plus 2, which is the second x, and an average, you add them up and divide by the number of numbers. So looks like our x is negative 3 divided by 2, which is negative 1.5, which luckily here matches. Let's do the exact same thing with the y's. I'll have to move down here because I wrote too large. 9 plus 5 divided by 2 equals 14 divided by 2, which equals 7. So the answer we get from doing our averages and the math work matches our coordinates. That's good news. Alright, let's look at the back. This is an equation of circles. We know circles that are at 0, 0 have equations like this. This is our basic circle equation. So let's see if anything is shifted, and then we reflect that in our equation. So the x actually isn't shifted at all, so that would have to be this, plus, the circle's been moved up 3. So remember, to the equation, we have to think about getting it back to the origin as a way to reflect on that, and it looks like it's been shifted 3 up. So to get it back, we would have to shift it 3 down. And our radius, if we count 1, 2, 3, 4, so 4 squared, that would be our equation for this specific circle, because it has been shifted up and it has a radius of 4. Alright, this one here is a little bit easier because the center is just at 0, 0. So let's write our regular equation, and then let's plug in our 50 miles for the radius. Alright, it says that you're an air traffic controller. We can use this equation to determine what we can see, and this is how far the airplane is away. So east and west usually mean x and y. South and north, x. This means y. If you plugged in opposite, I wasn't going to worry about that. Okay, 42 squared. Plus, that's how far you're away south, and we know if it is going to be equal, it should equal 50 squared. Okay, so if I use the calculator and I get 42 squared is 1764, plus 43 squared is 1849, and we know it would equal this. Okay, when we add these two up, we get 3613, and it should have been equal to this. So we know it's not on the circle. Now I have to reflect and see, is it greater than or less than? It is greater than, so that means it's outside. When you justify here, this would be a great method for the math, but we need to explain then. So I should see something about, I can't detect it because this number is greater than this number, so it is outside the circle. There needs to be some correlation where I can see that you understand the numbers and what they mean.